now dealing with questions on finance, growth, and decay. So let's look at question 6. 6.1. The key here is to read the questions very carefully so that you would be able to identify the correct formula that you have to use. So 6.1, Patrick deposited an amount of 18,500 rands into an account earning R percentage interest per annum compounded monthly. After 6 months, his balance was 19,319 rands and 48 cents. Now, if maybe after reading the statement the first time it still doesn't make sense, read it for the second time and the third time until you understand the statement completely. Now in question 6.1.1 we have to calculate the value of R. Now the first question that you need to ask yourself, am I dealing with a deposit or rather am I dealing with growth or decay? So from the question, Patrick deposit 18,500 rands. After 6 months, the balance will be 19,319 rands and 48 cents. So there is growth from 18,500 to 19,319 rands and 48 cents. So we are dealing with growth. So if we are dealing with growth, is it a once-off investment or are we going to make regular deposits so that we can check, we can see if the formula that is applicable will be the one of compound growth, since in the statement here we know that the interest is compounded monthly. Will it be compound growth or the future value annuity formula? So from the statement it's clear that Patrick deposited 18,500 rands into an account only once and then he never made other deposits. So we are dealing with compound growth. So for 6.1.1 the formula we use, A is equals to P multiplied by 1 plus I to the power of N. So now what is A? A, the final amount, P, the initial amount, I, our interest rate as a decimal, and N, the number of years. So now let us substitute and solve for R. The final amount after 6 months, the final amount is going to be 19,319 rands and 48 cents. The money is going to grow to 19,319,48, and then the initial deposit that was made, it was that one of 18,500 rands. So multiplied by 1 plus I. Now our interest is compounded monthly, so we are going to divide I by 12, and compounded monthly we are going to multiply N by 12. Remember, N is number of years, so the question is how many years? Here it is 6 months, therefore 6 months is how many years? 6 divided by 12 is 0.5. 0.5. So that will be what? The number of years, half a year. And then from here we can now do the calculations and solve for I and subsequently calculate the value of R. Alright, so let us divide both sides by 18,000 18,500. This will give you 1,044,296216, which will be equals to 1 plus I over 12 all raised to the power of 0.5 times 12 will be 6. And then from there, what we are going to do, we are going to take the 6th root on both sides. So the 6th root of our decimal number 1,044,296216 will give us 1,007250019 will be equals to 1 plus I divided by 12. Alright, and then from there, now we are now ready to solve for I. To solve for I, meaning I over 12 plus 1 is equals to 1,007250019. Then subtract 1 on both sides and then multiply both sides by 12. Then we'll get I is equals to, we will get I is equals to 0,087,000 and so forth. Remember, we always round off the final answer in finance. Therefore, what will be R? R will be equals to I multiplied by 100. Remember, I is the interest in a decimal form. So to write it in percentage form, we need to multiply I by 100. So 0,087,000,22298 multiplied by 100. Multiplied by 100 will give us 8,70% rounded off to 2 decimal places, of which it will just be 8,7%. That will be our R. Then 6.1.2, we have to calculate the effective interest rate. So now the formula for the effective interest rate, 1 plus I effective is equals to bracket 1 plus I nominal divided by M all to the power of M, where M will be the compounding periods, I norm, the interest rate, the nominal interest rate as a decimal, and I effective will be the effective interest rate as a decimal. So now let's substitute and solve for I effective and subsequently calculate the effective interest rate. So we have 1 plus I effective is equals to 1 plus the nominal interest rate. It is, we have just calculated it, 8,7% as a decimal. 8,7 divided by 100, 0,087 divided by M, different compounding periods. The compounding period, this is compounded monthly. We know that the interest rate is compounded monthly, therefore M will be 12 to the power of M 12. Then subtract 1 on both sides. I effective will be equals to 1 plus 0,087 all divided by 12 to power 12 minus 1. Then what will be I effective? Use your calculator. Use your calculator and your I effective. You should get 0,0905 5 4 and so on. Right, the decimal incomplete. Therefore, we have to calculate the effective interest rate. Therefore, our effective interest rate will be equals to, we take I effective, we multiply it by 100, and we are going to get 9,055 to 2 rounded off to 2 decimal places will be 9.06%. This will be our effective interest rate. Alright, now question 6.2. Question 6.2. Kuda bought a laptop for 10,000 rands on 31 January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. Now 6.2.1, the value of the old laptop depreciates annually at a rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0 rands? So 6.2.1 is clear that here we are dealing with depreciation. We are told that the value of the old laptop depreciates annually according to the straight line method at a rate of 20% per annum. So our formula A is equals to P multiplied by 1 minus I multiplied by N. This is the formula that we use for the straight line depreciation. So what will be A, the final amount? The laptop is going to reduce to 0 rands. 0 equals to the initial amount of the laptop. It was Kuda bought it for 10,000 rands. 10,000. Then multiplied by 1 minus I, our interest rate as a percentage, 20% divided by 100, 0.2 multiplied by N, which is the number of years. N, that is what we have to calculate. So let's solve for N. 0 will be equals to then 10,000 multiplied by 0.2N. 10,000 multiplied by 0, not 0.2N, but rather by 1 is 10,000, and then multiplied by 0.2N, 10,000 multiplied by 0.2N, 10,000 will be multiplied by minus 0.2N will be minus 2,000N, and then from there we are going to solve for N. 2,000N is equals to 10,000. Then 10,000 divided by 2000 will give us 5. Therefore n is equals to 5. Therefore the question, after how many years will the laptop have a value of 0 rands? Therefore it will be after 5 years. Now question 6.2.2. Now Kuda will buy a laptop that costs 20,000 rands. The question continues. Kuda will buy a laptop that costs 20,000 rands. In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th monthly deposit on 31 January 2024. The savings account pays interest at 8.7% per annum compounded monthly. Calculate Kuda's monthly deposit into this account. So reading the question carefully, you would see that here we are dealing with a future value annuity, because there is a deposit that is going to be made regularly every month. The statement, he will make his 60th monthly deposit, tells us that there will be regular deposits. And Kuda wants to buy a laptop that costs 20,000 rands. In order to cover the cost, he is going to make monthly deposits to buy that laptop. So we are dealing with a future value annuity type of a question. Therefore our formula FV will be equals to x multiplied by bracket 1 plus I to power n minus 1 close bracket, all divided by I, where FV will be our future value amount, x a regular deposit, I the percentage as a decimal, and n the number of deposits. Now Kuda, we have to calculate x, which is the monthly deposit. We have to calculate Kuda's monthly deposit into the account. So what will be the amount that Kuda must get at the end? It is 20,000 rand. So FV will be 20,000 rand is equals to x, that is what we are calculating, 1 plus I as a percentage, 8.7% compounded monthly, 8.7% as a percentage, 8.7 divided by 100, 0.087. But the percentage is compounded monthly, so we divide I by 12, all to the power of, now n, they have made things very easy for us. We are told that we are going to make what? 60 monthly deposits, and we are just going to make use of a straightforward future value annuity formula, because payments are made at the end of the month. Payments are made at the end of the month. We are not dealing with the situations whereby there are immediate payments and so forth. So n, number of deposits, 60, minus 1, close the bigger bracket, all divided by I, 0.087, all divided by 12. Then from here, now solve for x. Firstly, let's multiply 20,000 by 0.087 divided by 12. This will give us 145, which will be equals to x multiplied by, inside the brackets, let's have 1 plus 0,087 divided by 12 to the power of 60 minus 1. This will give us 0,5425404581. Then divide both sides by the decimal and solve for x. We get that x will be equals to 267,26, meaning x Kuda's monthly deposit will be 267 rands and 26 cents. We are having 261, ne? Of which, if we are to take 26, we are not going to get to exactly 20,000 rands. So here we are going to round up, even though the number after 6 is not 5 or greater than 5. We are going to round it up to 7, because the context of the question does not allow us to round down. If we leave it to 26, we are not going to reach 20,000 rands. So our monthly deposit has to be 267 cents and 267 rands and 27 cents. Alright, now question 6.3. Tino wins a jackpot of 1,600,000 rands. He invests all of his winnings into a fund that earns interest of 11.2% per annum, compounded monthly. He withdraws 20,000 rands from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. Now, how many withdrawals of 20,000 rands will Tino be able to make from his fund? Alright. So now from the question, it's clear that 20,000 rand is going to be withdrawn regularly. But when the question started in the statement, we are talking about an investment. Tino wins a jackpot of 1,600,000. He invests the money. So the question is, are we dealing with an present value annuity or future value annuity? So we are actually dealing with what? With the present value annuity. It is a loan. It is a loan, but Tino is not taking loan from the bank, but rather after Tino won 1,600,000 rands, he takes the money and loans it to the bank, and then he makes the deal with the bank that each and every month he is going to get what? The amount of 20,000 rands. So even though it started as an investment, but we're actually dealing with a what? With a loan. But a loan of which the bank does not loan Tino, but Tino rather what? Loans the bank. Then the bank is going to pay him back 20,000 rands every month. So the question is, how many 20,000 rands will Tino be able to withdraw? Our formula P is equals to PV, present value annuity, X multiplied by 1 minus 1 plus I to power minus N, close the bracket, all divided by I. So what is the loan amount? The loan amount is 1,600,000 is equals to X, regular withdrawals, 20,000 rands, then multiplied by 1 minus 1 plus I, interest rate 11.2% divided by 100, 0.112, then compounded monthly, you divide I by 12, then all this to power minus N, all divided by I, 0.112 divided by 12. So now we have to solve for N. So let's start first by multiplying both sides by I, which is 0.112 divided by 12. So 1,600,000 times 0.112 divided by 12. This is going to give us, I'm going to write it as a fraction. Or if you write it as a decimal, remember, write it in full. We only divide, round the final answer. So we get 4,800 divided by 3, which will be equals to, now we still have 20,000 multiplied by 1 minus, then inside the brackets 1 plus 0.112 divided by 12 gives us 757 divided by 750. Remember, this is raised to the power of minus N. Then what do? Then we are now going to divide both sides by 20,000. So we have 4,800 divided by 3. Then we are dividing this by 20,000. Then we get let's say from here we are now going to go here. We get 56 over 75 is equals to, then on the right hand side, when we divide by 20,000, we'll be left with what? We'll be left with 1 minus 757 over 750, and then this fraction is raised to minus N. And then now we have to solve for N. Therefore, transpose simplify, 757 over 750 to power minus N is equals to 1 minus 56 over 75. 1 minus 56 over 75 gives us 19 over 75. And then we are using logarithms now to find N. So exponent minus N is equals to log base of the base, 757 over 750, therefore log of 19 over 775. Therefore minus N will be equals to, what is log base 757 over 750 log of 19 over 75. This gives us minus 147,7978 688. Then multiply both sides by -1. We get n is equals to 147,7978688. N, which is what? The number of what? Of withdrawals. Ne? So the question is, how many withdrawals of 20,000 rands will Dino be able to make from his fund? So N, which is equals to 147,7978688, is the number of withdrawals. Then the decimal here tells us that there is going to be a last withdrawal of which it is less than 20,000 rands. Therefore, but the question only wants the number of withdrawals of 20,000 rands. Therefore, how many withdrawals of 20,000 rands? It will be only 147 withdrawals of 20,000 rands.